Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this. I'll tell it how I title in the title. But what I am sure of are our 4 goals for the day. Our first goal is going to be to review properties of and conditions for parallelograms. Our second goal is going to be to define a rectangle and investigate the properties of the rectangle. Our third goal is going to be to define a rhombus and to investigate the properties of the rhombus. And our fourth goal is going to be to define a square and investigate the properties of the square. So let's just go ahead and jump into our first goal, which is reviewing properties of and conditions for a parallelogram. So if we have a parallelogram, which means we have 2 pairs of parallel opposite sides, then you get all the properties of the parallelogram. So remember, we argued these properties from the previous lesson. So a parallelogram means that we have congruent opposite sides, congruent opposite angles, diagonals that bisect each other, and consecutive angles that are supplementary. I have a visual example of what this means. So if I have a parallelogram, this, number 1, is congruent opposite sides. This, number 2, is congruent opposite angles. This is number 3, diagonals that bisect each other. And this is number 4, consecutive angles that add to 180 degrees, which is a fancy way to say that is supplementary. All right? So having a parallelogram means that you get these 4 things automatically. All right? Now, if your figure has any of the following initial conditions. So let me make it very clear. I did this part of the review. Now I'm going to do this part, okay? So if your figure has any of the following initial conditions, it is a parallelogram. Remember, initial means start. So if your shape has congruent opposite sides, congruent opposite angles, diagonals that bisect each other, or consecutive angles that are supplementary, that means your shape is a parallelogram. And since your shape is a parallelogram, it inherits the other properties automatically. So if it does this, or this, we can then conclude it's a parallelogram, and then you get the other properties, okay? This is very important for today's lesson, okay? So if we get any of these, we get this, and then we get the other properties. Very important. Write that down. Make sure you have that written, because we're going to use that concept over and over and over again. So let me check off the first goal. I'm going to set up the second goal, and I will be back. I'm back. So let's go ahead and jump into our second goal, which is to define a rectangle and investigate the properties of the rectangle. So let's jump right in. Second goal. A rectangle is a quadrilateral with 4 right angles. So it's a 4-sided shape with 4 right angles. Here's an example. 1, 2, 3, 4 right angles. ABCD is a rectangle. What initial conditions does it have that makes it a parallelogram? So why don't you hit pause, see if we can figure it out. What makes this a parallelogram? All right, so hopefully you did hit pause, because I'm going to answer that question. There's actually 2 initial conditions that can be used to argue that this rectangle must be a parallelogram. The first is that it has congruent opposite angles. Okay, that's the first one. The second, well, actually, let me show you. These angles are congruent and they're opposite because they're both 90 degrees. These angles are congruent and opposite because they're both 90 degrees. The second initial condition that makes a rectangle a parallelogram is going to be that consecutive angles are supplementary. So, angle A and angle B add to 180 since they're both 90 degrees. Angle B and angle C add to 180 because they're both 90 degrees. Angle C and angle D add to 180 because they're both 90 degrees. And angle G and angle A add the 180 because they're both 90 degrees. Right? So our rectangle is a parallelogram, and in fact, all rectangles are parallelograms. So all rectangles inherit the properties of parallelograms. All rectangles have congruent opposite sides, congruent opposite angles, diagonals that bisect each other, and consecutive angles that are supplementary. Now, I want to focus on this right here for 1 second. All rectangles are parallelograms. Is the converse true? Switch the order. Are all parallelograms rectangles? All right, I'm just going to leave that as an open-ended question. It'd be good to kind of think about that and see if you can argue either way. All right, so visually, if I have a rectangle, it's a parallelogram, which means that I get congruent opposite sides and diagonals that bisect each other. Now, I left out the congruent opposite angles and the consecutive angles that are supplementary because they are the initial conditions that got us to a parallelogram. All right, so again, once we determine our shape as a parallelogram, we get all the properties of a parallelogram. And we need this because I want to talk about, in the second part of the second goal, I want to investigate the properties of the rectangle, but I needed to establish these properties because I needed to show you that a rectangle is in fact a parallelogram. So let me hit pause, set up the next part of the second goal, and I'll be back. I'm back. So let's go ahead and continue with our second goal, and that's to investigate the properties of a rectangle. Now, we want to argue that a rectangle has congruent diagonals, which means we want to argue that diagonal AC is congruent to diagonal BD. So why don't you hit pause, see if you can figure out how I'm going to argue that, and give yourself a shot at practicing these argument techniques. Remember, we only have two: transitive style and congruent triangle technique. So hit pause, give it a shot, and see what you come up with. Hopefully you hit pause. I'm back. Let's see how you did. All right, we want to argue that diagonal AC is congruent to diagonal BD. We are going to use the congruent triangle technique. So we want to argue for congruent triangles, right? Now, it might not be obvious what triangles we're going to use, and that's probably where you struggled with this argument. Now, side AC, or segment AC, and segment BD have to be part of the triangle. And to be honest, there's only one possible, or two possible triangles that have side AC in it: triangle ADC or triangle ACB. Right, and this same idea for side or length BD. There's only two triangles that it could be: BDC or BDA. Those are the only two triangles that we could have. So let's look at some facts, or actually let's first draw the two triangles separate from the picture, so it's a little bit easier to see. So here are the two triangles we're going to try to argue are congruent. Here are the two triangles we want to argue are congruent. My grammar is terrible. Argue congruent. Okay, I'll do that. So we want to talk first about triangle ADB, or ADC, sorry, ADC. Now we know that that's a right angle, okay? And here's the other triangle separate from the picture, and it would be triangle BCD, and we know that that's also a right angle. Well, let's list some facts, shall we? Okay, well, I know that side AD is congruent to side BC because those are opposite sides of a parallelogram, right? Remember, rectangles are parallelograms. So what that means now is that I know that that guy is congruent to that guy. Now, I can also say that side DC is the same as side DC by the reflexive property. Right? What do you say when you look at yourself in the mirror? Dang, I'm looking congruent today. So I could say that side DC, and I should write it like this, is congruent to side CD because the reflexive property. Okay. Now, our two triangles are congruent because of, don't say hypotenuse leg just because it's a right triangle, but they're congruent because of side, angle, side. So triangle ADC is congruent to triangle BCD because of side, angle, side, which means we can list the congruent corresponding parts, right? So, because of corresponding parts of congruent triangles are congruent, right? I can conclude that CA is congruent to DB, or AC is congruent to BD. And this shows that the diagonals of a rectangle are congruent. So rectangles have congruent diagonals. Okay? And that is what's special about rectangles. Rectangles are parallelograms, so they get all of the properties of a parallelogram. But what's unique about the rectangle is it has congruent diagonals. All right, so I'm going to erase all this, come back, make a bubble chart for a rectangle just so you know everything about it. And then I'm going to go ahead and start the third goal, defining a rhombus, and investigate the properties of that. So let me clean all this up and I will be back. I'm back, so let's go ahead and finish the second goal here and just wrap up what the properties of a rectangle are. So if I have a rectangle, it's a parallelogram because opposite angles are congruent, or consecutive angles add to 180 or are supplementary. So since it's a parallelogram, that means that opposite sides are congruent, and not only do the diagonals bisect each other, but they're also congruent. That's what makes that's just the unique property to a rectangle. Okay, the only parallelogram with congruent diagonals is a rectangle. Okay, now I didn't mention the two other properties of a parallelogram, which are congruent opposite angles or consecutive supplementary angles, because that's implied by being a rectangle. So that's how we got to being a parallelogram, right? All right, so now I can check off the second goal. And let's move on to the third goal, defining a rhombus and investigating the properties of that. So a rhombus is a quadrilateral that has four congruent sides. Quadrilateral is a fancy way to say four-sided shape. Here's an example of a rhombus. It has four congruent sides. All sides are the same length. That's what it means to be a rhombus. Now, notice that in a rhombus, the opposite sides are congruent. Right? And remember, opposite sides are congruent was a condition needed to have a parallelogram. So all rhombi, I think that's plural for rhombus, but all rhombi are parallelograms, which means all rhombi inherit the parallelogram properties. Opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. I left out opposite sides are congruent because that's what it means to be a rhombus. You get opposite sides congruent, and that's what got us to be a parallelogram. So I'm going to come back and talk about how we're going to investigate the properties of the rhombus, and let me clean all this up and I'll be back. I'm back. So let's go ahead and continue with our third goal, and that's going to be investigating the properties of the rhombus. Remember, we just saw that a rhombus is a parallelogram because it has congruent opposite sides, so the rhombus inherits all the properties of the parallelogram. So let's continue with our third goal. To investigate the properties a rhombus has, we need to include the bisected diagonals. Now, the 1 marks, that's what makes this quadrilateral rhombus. Congruent, all sides are congruent. Remember, the diagonals bisect each other. This diagonal got cut in half, and this diagonal got cut in half. Now, what makes the rhombus unique is that the rhombus creates 4 congruent triangles. All right, the bisected diagonals create 4 congruent triangles. Doesn't happen with any other 4-sided shape. And the triangles are congruent because of side, side, side. We now have to understand what the congruent corresponding parts imply. So I labeled all the angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so let's go ahead and start understanding what the congruent corresponding angles imply. So angles 1, 2, 3, 4 are all congruent. So what does it mean if all these angles are the same? Angles 5, 6, 7, and 8 are all congruent. So 5, 6, 7, and 8 are all congruent. So what does that mean? And finally, angles 9, 10, 11, and 12 are all congruent. So 9, 10, 11, and 12 are all congruent. What does that mean? So why don't you hit pause, see if you can figure out what this implies about the shape. Hopefully you hit pause. And if you gave it a shot, let's see if we are in agreement. Okay. So angles 1, 2, 3, and 4 are all congruent. Well, they add up to 360. Which means each angle measures 90 degrees. So, what this implies is the diagonals are perpendicular. That is a property of a rhombus. Let me put a square around that result. All right, angles 5, 6, 7, and 8 are all congruent. 5, 6, 7, and 8. They're all congruent. So what that means is the vertical diagonal bisected the angle, the opposite angle. So the vertical diagonal bisected. Remember to cut in half. So if these angles are the same, the large angle got bisected. If these angles are the same, the large angle got bisected. So the vertical diagonal bisected the opposite angles. All right. And finally, angles 9, 10, 11, and 12 are all congruent. 9 and 10 are the same, so that angle got bisected. 11 and 12 are the same, that angle got bisected, right? And so angles 9, 10, 11, and 12 are all congruent, so the horizontal diagonal bisected the opposite angles. So let me put a square around the what was important that we reasoned. The diagonal bisected opposite angles. And again, the other diagonal bisected the opposite angles. So the unique properties that a rhombus has are the diagonals are perpendicular and the diagonals bisect the opposite angles. That only happens in a rhombus. So I'd like to come back, make a visual representation of what it means to be a rhombus, and then jump into our fourth goal, which is actually going to be probably the shortest goal of them all, and you'll see why and hopefully understand. So let me clean all this up and I'll be back. I'm back, so let's go ahead and wrap up the third goal with a visual representation of what a rhombus does. So here I have a rhombus where I have 4 congruent sides. Because I have congruent opposite sides, that means that I have a parallelogram, so opposite sides are now parallel. And because it's a parallelogram, it inherits all the properties. So the first picture is showing a rhombus with congruent opposite angles, and it gets to have that property because it's a parallelogram. The second picture is showing that consecutive angles, x and y, add to 180 degrees, x and y, add to 180 degrees, x and y, add to 180 degrees, and x and y, add to 180 degrees. All right, the third picture was very, what we would call, busy. And it's showing quite a bit. And so first off, notice that I have diagonals that bisect each other. That's why there's 2 marks here and 3 marks there, which we get that property from the rhombus being a parallelogram. But what makes the rhombus unique is that the diagonals are perpendicular. They make right angles to each other, right? And not only that, but they actually end up bisecting the opposite angles. So that's why all these angles have the 1 mark and these angles have the 2 marks. So again, the characteristic that's unique to the rhombus as a parallelogram is the diagonals are perpendicular and they bisect the opposite angles. Okay, so let's highlight that with this. So the bisected diagonals are perpendicular and bisect opposite angles. So this is what makes the rhombus unique. Okay, so now I can finally check off that third goal, and let's move into the fourth goal and define a square and investigate the properties of. So a square is a quadrilateral that is a rectangle and a rhombus. We know what rectangles do, we know what rhombus do. So let's move on. Oh, by the way, here's an example of a square. Because it has 4 right angles, that makes it the rectangle. Because it has 4 congruent sides, that makes it the rhombus. Because a square is a rectangle, it is a parallelogram, so it inherits all of those properties. Diagonals that bisect each other, opposite angles that are congruent, consecutive angles that are supplementary, and opposite sides that are congruent. But we knew that because it's a rhombus. But because it's a rectangle, it also inherits congruent diagonals. So that's what's special about a square and a rectangle. They have congruent diagonals. Now, because the square is a rhombus, it inherits diagonals that are perpendicular and bisect the opposite angles. So a square does a lot, all right? And its diagonals are very unique. They're congruent, they're perpendicular, and they bisect opposite angles. Now, I'm going to come back and just wrap this lesson up and just give you some insight on how to look at these objects. So let me clean all of this up and I'll be back. I'm back for the last time, I promise. So let's go ahead and move forward with the last section of this lesson. Now, I want to go back and talk about this fourth goal. I actually did accomplish that. I didn't need to investigate the properties of a square because a square is a rectangle and it's a rhombus. I already investigated the properties of the rectangle and I already investigated the properties of a rhombus. So I don't need to investigate the properties of the square. We already did that. The square inherits all of these properties from both of these. Now, I want to move on and wrap it up and give you some tips for the homework. All right? And if you're able to answer these questions, you're in a great spot to answer any questions that will be asked about these shapes. All right, so know what a rectangle does. Are you able to Do you know all the facts about the rectangle, all of its properties? Each of those properties is a possible avenue for a question to be asked. Same for rhombus. Do you know all the properties a rhombus has? Each property is a possible question that you can be asked about. And finally, do you know all of the things that a square does? Each property is a possible avenue for a question. All right, so I'm not going to answer that. You should be able to answer those on your own. If you cannot, then you got to go back and review it. I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.